see. First off, I better make sure that my mic is working.
Hello?
Yeah, my mic's working. All right, and it looks like we're live. So let's go tell the world that we are live. Today we're making spaceships cruise actually work, I think. Indeed of. And then we'll pop on over into there and paste the same thing in. All right, well, now that we have set up our broadcast, I should tell YouTube. Exciting stuff. And we are now ready to keep working. So in the last episode, I did a whole bunch of stuff, and I ended up not really getting anything done. I spent like an hour and a half trying to make pathing work, and I didn't get it to work. But I took 15 minutes after that and made it work, I think. So basically what we've got is, if we're trying to find a path from the debug target to what we have, from this room here to this room here, it's going to go through these halls. So if we go over here and we trigger it, boom, it doesn't find anything because I forgot to reset the ship. Hold on. Oh, there we go. Now let's try it. Nope, still not finding anything. So maybe I didn't fix it. That's kind of strange. I thought I had. Well, great. Let's start from zero. So basically the idea here is that in these path element classes, grind, what they do is they reset all of their pathing when we ask them to. And instead of doing the method where each one of them detects just its own neighbors, I replaced that so that they try and find all of their neighbors, and if they find a neighbor, they tell their neighbor that they are connected. So that means that there's always going to be a two-way connection, and it means that you can have things like hallways or things like airlocks that connect to things that you wouldn't expect, and it'll still work out because they register both ways. So in order to do that, you just clear them all, and then you scan for them all. Now, the only thing about that is that it uses this live system, which means you're limited to one ship at a time. And I may fix that later on. But basically, when we find the path, where's the debug? Here it is. We reset the pathing here, and then we go on to do all of that stuff. But it looks like that's not working, because you can see how the neighbors are still 0 even after we debug the path. And the reason for that is because we're not in play mode. The live that we rely on doesn't work when we are in normal mode. It only works while we're in play mode. So if I clear this and try to find the path again, you can see how it complains a couple of no doors found, but then at the end it says SDORM integrated, hallway. So it found its way from one to the other in play mode. It couldn't find it in stop mode because live wasn't working. If I want this to work a little bit better, I should make it so that the ship is responsible for tracking these. And so that's the first thing I'm going to do. Here on the ship map, we have this ship architecture pieces thing. This is fine, but I think we're also going to want to keep track of the path elements. The ship architecture and the path elements are fundamentally different elements. One of them is all about bounding boxes, and the other one's all about what connects to what. But I don't know whether or not they need to be distinct. I think I can probably lump them together. And every ship architecture, well, no, because there are ship architecture things that aren't path elements, or let's go ahead and replace this with path element, and we will add in all of the ship architecture stuff to the path element class. So if we go to the definition, you can see how this is quite a simple setup. So we're just going to copy that and then paste it in up here near the top. There we are, up here near the top, after the static stuff. Boom. So this is just responsible for getting bounding boxes and setting up bounding boxes on the various elements of this object so that it can tell how large it is. And I don't think I even have... Oh, there's not even a gizmo drawing set up for it, so it's pretty basic. And that means that we don't even need this ship architecture. We can just completely replace this with a path element for everything. And we will just replace all. How do I replace? There we are. Boom. So that replaces them with path elements, and we're going to need to use the crew namespace to actually find those. So that should still barf a couple of times, and let's go ahead and take a look and see how it barfs. There we are. Path element does not contain bounds. That's because I didn't hit save. Oh, path element already contains a bounds. So there's several bounds and several maps. So let's just take a quick little look here. Map is already defined. It's just the difference is that this version caches it properly. So we'll just delete this version and keep the one that caches it properly. And then go back out to... I gotta rearrange the order of the buttons down here. There we are. So now, when we are trying to find objects, rather than just adding them to a list of all static objects live, we're going to go ahead and just use our ship map. So for that, we're just going to go out and find the map, which we can do by just passing it a map. So this stuff should probably be... Now, we'll leave it here, but basically, we're going to need to pass it a ship map. And then here, this will be for path element in map.elements. No, map.pieces. There we are. And of course, it's going to barf because we have edited out some stuff that it was using. But that's fine. We're not in a big hurry here. So we have to pass it a map. And we'll just do that by doing that. And now we have to delete the part where we sign up for the live list because we no longer need to do that. And now we should be able to do it while we are not in play mode. More importantly, we should be able to do it while we have multiple ships in play mode or even while ships are not technically loaded into the scene. And those things will help us out considerably. For now, we'll just reset this map. And you can see how it's giving us barf. There's no collider attached to Jorm Integrated Small. And this is the sort of thing I was expecting. So we're just going to add in a box collider here. And another box collider here. And another box collider here. And I think that might be everything. Anything else you want to whine about? Oh, it seems to be working. All right. So now let's try and see whether or not we can do this even though we're not in play mode. Perfect. So I'm also going to take out some of this debug nonsense I added in because I don't need it anymore. Everything's working. All right, so now we've got the pathing system working, but we're not actually using it to do the pathing that we need to do because what we need to do is to find options. So, in order to do that, we will need to start work again on this task test. The task test is responsible for finding a path from wherever it's starting to wherever the task is. And you can see how that's integrated here, but it's not actually functional. So our next step is to make that functional. And basically, we're going to need to have a public void setup path or determine path. And then we're going to want to just make sure that that's set up like it is. And we're going to find the start position based on where we're mounted. So if not start position, and start position equals get component in parent crew quarters, and then test again. So if it's still no start position, then debug.log error no start pause in task plus name. Return. Now that we have that path, what we can do is we can take the start position and we can ask it to find the right path. Now the question is whether or not the crew quarters descend from path element, and I don't remember. They do not. So these crew quarters are going to have a separate path element attached to them. And I can either change that to descend properly, or I can just go ahead and find the path element. For now, we're going to go ahead and add to the crew quarters a path element function. We can change exactly how we do it later. Return get component path element. Nice things about getters and setters is that they will arbitrarily be replaceable later on. We can use them as stubs. And so what we'll do is over here on the task, we'll find that path element and we will tell it to find us a path. Pathing between. And we now need to give it a target. Well, the target that we're trying to find is whatever is attached to the target, the duty target. Now the problem is that the duty target is not a path element as far as I know. No, don't peek, just go there. It doesn't descend from path element. We're going to go ahead and descend from path element. Because that way we won't have to have duty targets that are separate from path elements, and we can just specify a duty target, and we'll just go ahead and pass that in like so. And then we need to give it a list of possible targets, and that's going to be out path. And we're going to change out path so that instead of a list of transform, it's a list of path elements. There we go. And we're also going to go ahead and make that something we can click on. Like so. Keelblock says, you're a Unity buff, right? Well, I know a lot of Unity. I've been doing it for a while. If you have questions, feel free to ask. So over here, I'll just clear this out. You can see there are a couple of problems. There's no setup for position on the path, and that's because it's actually called pause. But the problem is it's actually a ship position, so we're going to go ahead and say transform dot, because that'll be a global position, which makes more sense for this particular function. Grind, 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 and no more bugs, lots of bugs. So here we are. And that's the reason we're having bugs is because this should be a 0 length path. So there we are, because I just changed it. All right, so now if we draw this script, it'll try to find a path, but it's not going to manage it. So if I determine path, it just says, I don't know where I'm going. We're just going to start here and then stop. So when we do that, we need to actually have a value that tells us that the path is functional. Float pathlen equals. If pathlen is less than or equal to 0, then we want to debug.log error no path from plus start position.name plus 2 plus duty.name. Come on, fingers. And then we'll clear it, path.clear. I've got the hiccups. All right. Keelblock says, if a game object has multiple jobs, do I put them in separate scripts or have one script per object? So my take on Unity is that you should use components really aggressively. So if you want to take a look at how I do that, here is my dorm integrated room. This is the dorm that has a bathroom in it. And you can see I've got a path element script, I've got a crew quarters script, I've got a mesh filter script, I've got a mesh renderer script, I've got a box collider script. And all of those have basically one thing they do. Some of those are Unity built, some of them are built by me, but they're very focused on exactly one thing. The path element script is only responsible for finding paths, and the crew quarters script is only responsible for tracking crew. Because Unity allows for this kind of modular construction, I use it, and I use it really aggressively. And I think you should too. If you want to know more about how to do that, I actually have several tutorials on my webpage or on my YouTube page. You can just go there and see Creating in Unity is a big long playlist, and it'll tell you all about how to do that. So in order to make this work, we're going to need to change the layout so there actually is a path connecting them, like that. And if we take a look here, this is the path that we have been using, or rather the target we have been using. It is the engine door. And you can see how the engine door doesn't have any colliders or anything. So we're going to go ahead and add a box collider, which we'll go ahead and just leave it like that for now. So that should be fine, but the problem is that I'm not 100% sure it's going to work because we're using a getComponentsInChildren call, which may not actually get this door. Let's find out. So if we take this task test and we tell it to determine the path between the engine door and the small dorm room, it gets barf, no path. Now, presumably that's because the door isn't getting set up right, but we can tell that right away because we can see what neighbors it's got. And it has the small bridge room as a neighbor and the hallway as a neighbor. Really? The small bridge is way the hell over there. Oh, we didn't reset the pathing. That's the problem. So in order to have this actually work, we're going to need to reset the pathing, at least at the moment. And to do that, we'll just go over to the start position or the duty, either one, and tell it to reset. I guess we just, yeah, duty.reset. Okay, so duty is descended from path element, and path element has a reset function, reset pathing, and we just pass it the map. So what we're going to do is we're going to have another function to call that here. Public void reset ship-wide pathing. And it's just going to do this one thing here. And so, when we call the task, we're going to call reset ship-wide pathing, and that's all we need to do, and that'll hopefully work. Later on, we'll do pathing a little bit differently once we've figured out when things are changing. And we may need to reprogram this whole shebang because it's getting a little bit clumsy. But that's what you have. So we still have no path. I didn't chest it right, hold on. We still have no path. But if we take a look, let's see where we're connected. We're connected to the engine door and the hallway. So there is clearly a path because this hallway is now connected. If we take a look at the hallway engine door itself, you can see how its neighbors contain the hallway. So we're working here. We are connected in a big long chain throughout all of these objects, but for some reason the actual path test isn't catching it. Interesting. Finding path between target.name and name. Let's reverse those. Grind, 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 and let's try it out. So here you can see that it says it's finding a path between this, and then this, and then this, and then this. And it doesn't say anything else. It doesn't even say that it failed. That's interesting. So if neighbors.contains target, then add that and return. So the problem is here that it doesn't look like this is working. We're going to go ahead and try it. Debug.log neighbor is target. Grind, grind, grind. So here we can see that the neighbor is the target. So you know what? I think this is working, and we just aren't... Yeah, see, look, it's working. I'm just an idiot. So if we take a look here, the reason I thought it wasn't working is because the red line is a little hard to see, but you can see how it is moving along with this piece, which means it's working. The red line is exactly as intended, although I may have just busted it. Nope, it's fine. And that means that all of my debugging was just because we were caching an out-of-date path element. So we'll go ahead and clear that. So basically what I've just done is I have set up a situation where it will go and find whatever connection it can. But the problem is that the way I've set this up is pretty clumsy and not in a way that I would recommend. I get the proper path length, but I don't have a proper progression. So if I move from my... so let's just give a quick example here. If I take this and move them out 1, 2, 3, 4, and then I take this and bring it in and bring it around, like so. So now what we've got is a setup where this bridge module is between the crew quarters and the engine. And what I need to do is I need to make it so that the bridge module has priority. And if the bridge module has any objects to offer, then the bridge module is the one that gets, that everybody does what's on the bridge, and nobody goes past the bridge until all of the bridge's duties are done. To make things more complicated, the engine is not actually a taskmaster. It's just a task target. The bridge might be the one actually assigning the tasks to there. So what we're going to need to do is come up with a taskmaster class that creates tasks. And then what we're going to have to do is find which taskmasters are directly connected to us and which taskmasters flow out from there, and so on. The problem is that I didn't build this with that in mind, so now I've got to retrofit it. Zargi stopped in to say, what are we working on today? And I think I've been just explaining that, and he just happened to come in just as I was starting. So in order to make this work, what we're going to need is we're going to need a way to chain together maps of connectivity, which, you know, we've got with a small set, and we're just going to do that again with a more chunky set, and that's going to be taskmaster objects. And so we've got path elements, we've got path hallways, so we're just going to add in a task. We're going to call it a task controller task creator. I mean, taskmaster is what I want to call it, but I don't want to. I got piece of hair or something on my keyboard. There we are, good. We'll call it a task, administrator. We'll call it an administrative post. We'll call it a post. That's what we'll call it, a post. Easy as pie. So we'll open up this post, and we're going to put it in the correct namespace crew. And we're going to describe it. Yay! Look at that. The post class is responsible for A, deploying duties and tasks, and B, keeping track of connectivity to other posts. This doesn't feel right. Hold on. Fundamentally, what we're talking about here is a network where the system is broken up into different segments. So this here is one segment, and this here is another segment. And then a large ship, there might be, 50 or 100 different segments. It's impossible for us to keep track of which direction from this is which segment unless we're also keeping track of it by door. And if we're keeping track of it by door, then we're going to need to keep track of each door's connected elements. And the way to do that is to have groups, regional groups that are just lists of task doors. This sounds dumb. There's got to be a better way to do that. You know what? Give me a second. I'm going to go ahead and pull up an art program in Doodle some and think about this. And if you've got ideas, feel free to let me know. But while I make the art program do what I want, you're going to see Phoenix Wright. And I hope nobody has any objections. Alright, I think that's fine. Move this around, move that around. Make lots of squeaky noises, and we're back. Hooray, right? So if we put this somewhere where mostly it'll be on the screen. Oh, no, not there. Why did you snap? There we are. We'll just make it nice and big. And then I'll move this so that I can see it and the chat window. Hooray! So now we're ready to think about what we're actually trying to accomplish here. So, if we have a room, so here is our dormitory with our dudes. So this is the dorm, and people exit out of the dorm in search of work. And the idea is that there are various hallways, which might go anywhere, right? And, no, that's not the eraser I want. There's the eraser I want. And as you go out into the hallways, there's going to be certain task regions. So here is a task region that you might work at. And maybe that's a bridge, or maybe it's a maintenance corridor or something. And here's another one. And then if you go through and it has another door on the other side, there's going to be other maintenance or other task areas that you can reach, like this. There might also be customized rooms which have an effect when you pass through them and change how long a task takes and what the results of a task are. For example, maybe there is a nice sleeping or waiting room, social area, and that'll add time to your tasks, but it'll make you happy. So depending on this kind of setup, what we want to have happen is we want all of the crew members to divvy up these tasks here, and only when this task is actually done, only when this is completely out of tasks, does it move into the next area. Now, in order to set this up, we need to understand where they're going to go and whether or not there is a set of tasks that need doing. And this is a little bit more complicated because there may be another dorm right here. And that means that there would be 8 people splitting up their tasks between these two areas. So really what we would need in order to get this correct is we would need to know that on any given hour, because we're doing this hour by hour, on any given hour we need to know how many available crew. In this case, it would be 8 because nobody's been assigned yet. But, you know, if someone's been assigned, it might be 6 or 4 or 2 or none. Then we need to know how many tasks are available. Now, the way we fill this out is we get first tier connections. So, first neighbors. We'll call them neighbors. Neighbor posts. And that would be here and here. And so that would be, you know, a certain number of tasks. If this neighbor is out, if this dude out, add next section instead. So now you've got barking dogs and heaters and geez, suddenly got real loud. All right, so this is the key that I was missing. Logically speaking, this area is distinct, and it doesn't have any knowledge of any of the areas past it because it doesn't need to. That's not a pathfinding distinction, though. It's enabled by the pathfinding map underneath, but it doesn't replace the pathfinding map. The pathfinding map simply allows us to chunk it up properly. And because of this, when we have this unit, when we ask any given location for tasks, we tell it what door we're coming from. So we ask, tell us tasks, we're from door 1. And that way it knows that if it's out of tasks, it should give us tasks from the other door. And sounds like the dog is really pissed off, which is strange because there's never been a barking dog at my place before. I hope this isn't a standard now. All right. So with this in mind, what we need to do is we need to have the posts organize subgroups based on door. But we also need to have those subgroups. So that's what we're going to build now. We're going to go ahead and build those subgroups. So we'll call it a barking dog subgroup. No, a sector. We'll just call it a sector. No, that's not how you spell sector. That's how you spell sector! All right, so a sector is also going to be in the namespace crew. Hold on, I want to look through the window. I got no idea where that dog is, but for all I know, it could be in my living room. I don't know if you can even hear that. It is really obnoxious. One of those toy yappy dogs that really shouldn't have ever been bred in the first place. So a sector is a group of functional rooms that is edged, a group of functional rooms that is all connected with no barriers between rooms. And that should be enough for this setup. And we're going to need to have functional rooms as something we've got. Now, functional rooms should include crew quarters and task or posts, and it should also include any kind of element that the crew can use. So we're going to have to make a script for that. We'll call it a functional room since we already have. Oh, it has to be in namespace crew. Any room that the crew has something to do with, such as crew quarters, posts, social rooms, airlocks, etc. Logical bulkheads, etc. So it's anything that can cause a barrier. So in order to make that work, we're just going to delete this and call it done. Now, in order for us to descend from that properly, we're going to go over into the crew quarters and descend from it. Functional room. And we're also going to go over into the post system and descend from it there. Functional room. No problem, right? So here in our sector, we're going to go ahead and have a list of functional rooms. Right, and what we're going to need from a sector is we're going to need to be able to initialize it. And this is the part where it doesn't even have to be a mono behavior. In fact, it doesn't make any sense as a mono behavior. So we're going to delete the mono behavior stuff, but we are going to make sure that it is serializable. And when we initialize it, we're going to need to add the rooms to it. So from that, we're going to go ahead and create a function here. Public void initialize from, and then we're going to pass in a ship door. Now the reason we're passing in a door is because the rooms are edges, and I need to know which direction from the edge that we're going to go. So once we pass it a door, we can find all other connected doors by simply neighbor hopping, and that's a fairly basic way to do things. So to do that, we're simply going to take that door's room and add it, and then check and see whether it has any neighbors and add those and so on and so forth until we find a room that is a functional room. We add the functional room, but we don't move through it. So public void add door, ship door, door. So the way that this works is that we are going to find the room that we're in. And so for that, we're going to get a functional room equals door.getComponent functional room in parent. If room, then we are going to, there is a functional room, stop here. We're going to add it and then stop. So this should be above this crap. Rooms.add room. And we're going to also want to stop, return. There is no functional room, so we'll door hop. And so to do that, we're just going to go through all of the other doors in this area. And to get that, we're going to want the path element. Now, the doors currently don't have a link to the path element, but you know what? They should. So we're going to go over, don't peek. There we are. And we're going to get a door, so, or a path element. Public path element crew.path element path element get. And we're just going to go ahead and first try and get it from the parent and then try and get it from ourselves or vice versa. So crew.pathElement. I guess we'll just go ahead and say using crew, or even put this in crew, but so pathElement. PathElement e equals getComponent pathElement. If e, return e. Return getComponent in parent pathElement. There we go. And that should give us the ability to just ask shipdoors for their path element. So that's a little bit easier than trying to find that ourselves every time. It's a much more reliable way to do it. So we're going to just grab that sector. Where is it? There it is. And we're going to go and use that element. So door.pathElement.doors. See? So for each shipdoor d in door.pathElement.doors if d equals door, continue. Don't go out the same door you came in. Otherwise, we're simply going to move through. Now here's the thing. Right now we're doing this recursively, and that may bite us later. So we're going to add in a little to-do note. To-do, make non-recursive for depth safety. Now here's the other thing. The reason that it has to be, we're going to do that now that I'm thinking about it, because the reason that we have to make this non-recursive is because if it's recursive, then we end up with a problem where we'll go in circles. So in order to prevent us from going in circles, we're going to need to add all the doors to a list of doors that we've processed. Which is not a bad idea. We'll just say protected list ship door processed doors. And then here, we're going to go ahead and see if the door is already in the processed door list, we'll stop. If processed doors dot contains d, then continue. If it's not in the process list, then find the other half of the door. So for that, we're just going to say ship door neighbor equals door.pathElement dot map dot door find door, and then we're going to pass it the position of the door we're currently on, and we're going to tell it to ignore that door's transform. That way we'll get back the neighbor door. And if that's in process doors, we're going to continue as well. So if we get this far, then what we're going to want to do is go through that door. And we're just going to go ahead and add that door to the list. So to unwrap it, all we have to do is move this into the add door function, like so. And then also add an open doors. And these both need to be initialized. Like so. And so here what we'll do is we'll say open doors.add door. And processed doors.add door. No, wait, we don't want to add the process doors. We'll say while open doors dot count is greater than 0, door ship door equals open doors 0, open doors dot remove at 0, processed doors dot add door. Oh, there we go. So what we've just done is we've let's call this start door. What we've just done is we've transitioned over into having an unrolled function. Recursion is a little bit easier for us, but it's harder to keep track of state, and we have a problem where there is a recursion limit, and we might hit it on large ships. So instead, what we're going to do, we're just going to move through the doors And we're just going to add the ones we haven't explored to a list of doors that we're going to explore. And the ones that we have explored, we're going to skip. So here, what we do is we grab the door and we find the functional room. If there is a functional room, then we're going to want to make sure to just stop there. If there is no functional room, then we're going to want to find the rest of the doors in the area. And so we check and see if it's processed. If it's processed, then we continue. We find the neighbor door. If the neighbor door is processed, then we continue. Otherwise, we're going to add it to open doors. Is this right? I think so. Let's just check for a second here. Neighbor. So basically, the key here is that we want to open the neighboring door. But what we would like to have happen is we would like to have it only connect to the other doors in that room and not pass through that door again. So let's make sure that's what happens. We add it to the list. It comes out of the list as a ship door. We find the functional room, and then we look through. Yeah, so I did it right. Good. We look through all the doors, and if it's the door that we specified, we don't go through it again. And that's the key here. So we're closing the doors behind us as we go. And to double down on that, what we'll do is we will we'll mark the door we're processing as well. So this one will get marked as processed. The one on our side will get marked as processed. So the one on the other side gets marked as open. And that means that even if there's something wrong, it's not going to go back through this door because this half of the doorway has been marked as processed. And this should create a full set of connectivity through any given set of rooms. The only problem is that we don't have it set up quite right. So here in the functional room, what we're going to need is a list of all of the doors in the functional room. And we're also going to need to have a list of all of the sectors that are connected to all of the doors. Now here's the problem. Unity is really bad about serializing these classes if they're referenced in multiple places. Which means that we may end up with sectors that are duplicates. And that's not very useful. So what we're going to need to do here is, I think we might need to switch the sector back to being a mono behavior. I guess that's probably for the best. You know what? We don't have to do that. I'm thinking about it, and it's okay if there are duplicates. This is a very lightweight class. So over here in our functional rooms, we're going to have a list of doors. So public ship door doors get return get doors get components in children door. And then we're also going to want to have a list of all of the sectors. And the good news is that the doors always return in the same order. So the sectors can just be the same index as the doors. Sectors with indexes that match the doors. And then we'll have a public void create sectors. And that's going to be something we can select. And what we'll do is we'll start by clearing out the sectors that we currently have. Sectors.clear. And then we'll do a for each ship door in doors. And we'll create a new sector. Sector S equals new sector. And S dot initialize from door. Easy as pie. And then we, of course, add it to the sector list. And let's see whether or not this works. Now, of course, we currently have no functional rooms defined. So let's take a look here. This is something that needs to be a functional room, and it isn't. So we're going to drop in a post function here. That's a functional room element. And now this is a functional room with sectors. And over here, this already has the crew quarters, which is a functional room. So we're going to save this, because there might be an infinite loop. I didn't check very hard to make sure there's not. And then we're going to tell it to create, the sectors. Now there should be exactly one. There are 0. Oh, it barfed. Let's take a look here. Rooms doesn't exist. Oh. I got lazy. Too much Unity. Grind, grind, grind. Clear. Size 1. Rooms, dorm integrated small. But that's not how it should have been. Is it because the neighbors? No, the neighbors exist. So this should have also been included. So here you can see that we've got just itself in both of these. It's not actually going into the other rooms. So we're going to go ahead and put in some debug lines and see if we can figure out why it isn't working. So what we're going to do is we are going to add in a list of things we're working on. Debug.log. Working on door, and then plus door.parent.transform.parent.name. And that'll at least tell us how many doors it's checking. So let's go over here, let it recompile, and tell it to do the work. So it's only working on itself. It's not finding the other connected door. Now, the question is why that is. So if we get here, it tests if there's a functional room, and if there's a functional room, it stops. And I think that's the problem, isn't it? Because this is a functional room, and it stopped. So what we've got to do is, if it's a functional room, I guess if it's our first functional room, we probably need to not stop. No, if it's the room that we start on. Okay, so if door does not equal start door, continue. Grind, 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 and no, that didn't help. Debug.log ending sector on, and then room.name. Debug.log door hopping. And we're just kind of debug.logging. I know that what I should do is I should step through it, but I don't know how to hook this up. It's a new IDE, and I don't really know how to make it do the things I want it to do right now. So we're going to do it with debug statements. So we actually do get to the door hopping call. It only gets called once, though. And it says if D equals door, then continue. So don't move through the door. We're going to go ahead and... So here's the issue. It's clear that the very first door is the problem because it has a special case. So what we're going to do is we're going to say if D equals start door, or if D doesn't equal start door, then do these things here. And otherwise we find the neighbor, and that's that. So that should work. There's some special case logic for the very first door because it's in a room that would normally cause us to not go through any more doors. Oh, wrong one. There we go. Object not sent. Working on SDOR, working on hall. Oh, okay, so there is a problem here. Okay, that's fine. I don't really care if the debug statement is not good enough. So we're going to go ahead and clear this out. And try one more time. You know what? Let's drag this above the path element. We still got a barf here. Save. Why aren't you... If room? Did I... Okay, I must have accidentally deleted something. Hello? Hello? McFly? There we are. For some reason it was not recompiling. Huh, it's still giving me this barf here. Object is not set to an instance of an object. Start door on line 27. Door isn't set to an instance of an object? Did I make some kind of really dumb basic mistake? No. Okay, so somehow... Oh, I see what the problem is. I'm adding the other side of the door, even if there's no other side of the door. Of course, I kind of forgot that neighbor has to exist, so... If not neighbor... So if there is no door, which is something that happens a lot, especially if you're talking about hallways... But once again, we're going through doors. Idiot! Why am I going through doors? Oh, such stupidity. Because I don't want to go through doors. The whole point of this was to use the goddamn mapping system. And I just totally failed to do that. Okay. Start over. This is not what I wanted to do. I have to use path elements, not ship doors. Oh my gosh. Can you believe how stupid I am? I just wasted 45 minutes. Because we don't need to know about the doors themselves. So start door dot path element. There it is. And we'll just add that. So open pe dot add start door dot path element. There we are. That's a bit better. Now the problem with that is that we're going to go ahead and add that to... Yeah, I think we're going to want to add that to the list of rooms if it exists. No, wait, we're not. That's fine. We can do it later. Okay, so while openpe.count is greater than 0, path element next equals openpe 0. And then we say processed pe dot add next, and functional room equals pe dot get component, and it's not in parent, and it's not called pe, it's called next. There we are. So if there is a functional room, then we want to stop here unless it is the very first room. So to check on that, we're going to have to keep track of the very first room a little bit separately. So path element start equals start door dot path element. There we are. And then down here, we're going to add the functional room to our list of functional rooms, but then we're also going to say that if it's not the start element, then stop. Don't go through any more doors. So regardless of whether or not this is a functional room or a standard path element room, we're going to go through all of the other doors, but we're not calling them doors because they might not be doors. We're going to just go to all of the connected path elements. And that's actually quite easy. So we'll just go here, say path element, and we're going to be going through it in, I'll call this PE, and we're going to be going through it in terms of the next.neighbors. There it is. And so when we go through into a neighboring path element, we're not going to have to check any doors or any bullshit like that. All we're going to need to do is see whether or not that path element is in the list of processed. So if processed PE dot contains PE, continue. Otherwise, add it to open PE. It's that easy. There's no longer any false positives or anything like that. And what that means is that we're going to go through every single one of these, but only once, because we're adding it to the processed PE every time that we go through it. So even if it's a circuit, we're not going to get an infinite loop. This requires us to be a little bit less dumb than I have been being, and I have no excuse for that. It's Saturday. I should be nice and fresh, but I am apparently very stupid. Right, so here we are. We're in the crew elements. We're going to go ahead and hit that create sector button, and we're going to take a look, and it's an infinite loop. Hooray. So I had a sneaking suspicion that this might happen. I don't know why it happened, but the good news is someone gave me advice yesterday, or last Wednesday, on how to kill this without causing it to destroy the OBS screen. So wasn't that fun? Let's reopen Unity. Grind, grind, grind. You know what? I'm going to go ahead and give you Phoenix Wright for a bit while I do this. Unity is taking forever to open these days because they decided that they were going to bog Unity down with 800 things that I don't care about. Grind. I guess I'll bring you back. Nope, that's attempting to stream Dragon Quest XI, which I don't think is running. There we are. We're back. So, here we are again. Here is our A-class ship. We're going to drag that above the animator and reset it. And when we tried to fire off our crew quarters script last time, it barfed. And the reason for that was unclear. First, let's go ahead and do a debug path. That will initialize all of the neighbors, and that'll get us ready for the rest of this. But when we were telling it to do this, it was barfing, and I'm not sure why. So in order to keep it from being an infinite loop, we've got to add in a little bit of safety measure. So we're going to go ahead and just break here. But what we're going to want to do here is debug all of this crap. So debug.log adding, and then pe.name. And then up here, we're going to go ahead and I found the problem. Apparently, I deleted that line back when I was refactoring. I just deleted a line at random, which is always a really great sign. You are a good programmer if you randomly delete lines without noticing. I'm definitely going to have bugs if I keep doing that. All right, so there we are. We've created the sector map, but again, it doesn't contain enough information, and I don't know why that is. Here you can see that the path element next is, in this case, not the thing that we would like to see. Next is barfing, which is a little bit strange. There shouldn't be any null neighbors. Let's take a look here. Oh, well, this doesn't have a path element. Huh. That explains it. I don't know why it doesn't have a path element. That's kind of strange. Well, let's go ahead and reload the ship. Boom. And once again, we're going to tell it to just find a path real quick so that we can set up the neighbors. And you can see how it said that it doesn't have any neighbors. So that's wrong. There's something going wrong here. You know what? Maybe I should pay attention to some of these debugs. p.neighbors.clear, and neighbors is null? Why would neighbors be null? Neighbors can't be null if you've serialized it. Is this a serialization bug because I crashed Unity? That does happen sometimes. If not if p.neighbors equals null, then p.neighbors equals new list path element, else p.neighbors.clear. My guess is that this is a serialization bug due to crashing Unity. But I also wanted to add in the reset shipwide pathing as a context menu. There we are. So now we'll just go ahead and reset the pathing. And there you can see we've got a neighbor. And all of our people should be set up with neighbors now. Good. Let's go ahead and give this a shot again. Ending sector on SDORM integrated small. That's an interesting thing for it to say. Why would it say that? If we take a look at functional rooms, I've got a sector here, so let's reorder this a little bit. So it's saying that if the room doesn't equal the start element, it should say that it's ending the sector there and move on. Ending sector on SDORM integrated small, but we started on SDORM integrated small. The ship door that we're starting on should be the first door of SDOR integrated small. What is going on? See? If room... Oh, because it's the functional room. Of course. So what we actually want to check is if there are... if next is equal to start element. There we are. That's better. Because the functional room and the path element are not the same class. They're just the same game object. I could also compare their game objects, but this is just as easy. So, now let's try it. And there might be an infinite loop. Let's find out. Nope. Good. And you can see that now it is correctly bordered by the two objects in question. And here you can see that both doors lead to the same bridge integrated small path. Now I think the reason for that is because of this special case where we look for all of the other doors in our door. And that's really not what we want to do. We want to limit ourselves to just the door in question. And that's kind of a special case, and this is really the issue. I think that what we're going to want to do is find the door connected to our door and run off of that instead. So to do that, we're going to just say ship door other side equals start door dot path element dot map dot find door start door dot position and start door dot transform. Start in a, well, if this is like two rooms that are exactly, hold on, that's only going to work if, okay, so here's the problem. I add our current room, which is a starting room, to the list of open elements to search. And then when I get to that list, I say, well, go through all of the neighbors. But in reality, I only want to go through one neighbor, whoever is connected to the door in question. So in order to do that, what I need to do is I need to say, if this room is the first room, you have a whole bunch of special rules. I can either do that outside of the loop or I can do that inside of the loop. Either way, what we're going to want to do is here. So if next equals start element, then we're going to want to special case only go through the specified door. Then we will go ahead and say ship door next door equals start door, or equals start element dot map dot find door next door dot transform next door dot position and next door dot transform. If not next door, return no connected rooms. Otherwise, we're going to want to add the next room to our OpenPE. So OpenPE.add next door dot path element. There we are. And that should work. It should work if I have a brain, but I do not. There we are. So let's go ahead and clear this out and search again. There we are. That's better. So you can see that it didn't find this this post that we've got all the way over here. And so that's our next step. We're going to turn that post on and make sure that it can be found. We do have a duty, but the duty is not a pathing element. Or rather, it is a pathing element. It's not a functional room element. So we're going to have to add a functional room element to this if we would like it to be bordered here. And I think that's probably worth doing. We'll just add just a functional room element just for the sake of having it. And we'll figure out the specifics later. Anyway, back to the bridge. Now if we recreate these sectors, you can see that we've split it into, on one side, the crew cabin and ourselves, and on the other side, the engine room and ourselves. The solar rooms are separated from it, but we can also add them in, like so. But they also need to have a path element dropped in on them, like so. And with that set up, we have to reset the ship again, like so. And then what we can do is try it one more time. It didn't work. There we are. Now you can see that we have separated this out into different regions. And that works pretty good. The only issue with this is that there's no drawing mechanism to show you what these regions are here in scene view. We could go ahead and try and draw them, so let's go ahead and do just that. In the post, we're going to have a method to draw that stuff. Not post, in the functional room. So in our functional room, we are going to have a public void onDrawGizmos. And we're going to say gizmos.color equals new color. And that's going to be just a gray. So how about a 1110.4f? And we're going to go through all of our sectors. For each sector S in sectors. And we're just going to draw a line all the way around, and then we're going to cap it off by going back to where we started. So for that, we're going to go and say each sector has its own drawing. Yeah. For each functional room F in S dot rooms. And then we're just going to say draw a line. Gizmos dot draw line. And it's going to be from, I guess this needs to be a 4. For int a equals 1, a is less than s.rooms.count, a plus plus. Gizmos.drawLine s.rooms a minus 1 dot transform dot position plus vector 3 dot up times 3, comma, same deal, but without the minus 1. And then at the end, we're going to connect the front and the back. Rooms 0 to the main count. And now, if we let this run, there we go. It doesn't seem to be creating a good loop, though. As you can see, I guess it's a loop, it's just that it's a weird 3D space, so it doesn't look very loop-like. What we could do instead is we could determine the scope and try and draw a bounding box or something. But I think this is okay. I don't see any huge reason why we have to make this more complex than this. But this is a little bit of a complex area, and I'm not 100% sure that this is the right architecture for what I'd like to do. We create a shipwide map, and then we have to create a second shipwide map where every single room that has a function to it keeps track of all of the other sectors that it's connected to. And that's kind of complicated, but I guess it's not too bad. It's just a list of pointers. It's not like it's going to be a huge deal. I'd like a more elegant solution, but I can't think of one. This should work, though, because what'll happen is the room here will say, all right, my sector is the bridge and myself. I'm going to go ahead and ask for all of the possible tasks from each of these people. And the bridge will say, okay, well, the possible tasks are drive the ship. If you've driven the ship and I'm out of possible tasks, I will simply ask all of the other sectors, not the one you're from, but all of the other sectors for tasks that they have. And I'll add them to the list. So in order to do that, what we're going to need to do is add in that function to the fundamental functional room element. So if we take a look at the functional room here, it's going to need to have the ability to return a list of tasks. So that's going to be fun. Public void, no, public list task local tasks. It's going to be a public virtual. And public virtual list task tasks. And then ship door from door. There we are. So what we're going to do here is we're just going to return a null value. But I think what we actually want to do is we want to look for all of our duties. Duties are currently stuck on the engines and shit, and that's not what we want them to be. So this here is nonsense. We're going to go ahead and make this a mono behavior instead. We actually switched it from being a mono behavior when I had a different idea of what I was trying to do. So what we're going to do is we're going to find all of the duties and do them. So public list duty, or actually it's an array duty duties get. So return get components in children duties. Here's the problem. I'm actually not sure if that's going to work if the duty is on the object itself. So it might be best if we did it both ways. So that's going to be a list rather than an array. So duty A equals, and then that, and then it's going to be duty B. I guess we can just use A again in a second here. So for each duty D in A, list duty D's equals new list duty. D's.add D. And then we're going to repeat the process. There we go. And then we're going to return DS. So that'll give us a list of all of the duties that we have. Now over here in duty, there's no ability to return tasks because we haven't built it yet. That's what we're going to do now. So public list tasks. And we'll just return a new empty list at this point. Like so. So over here in our functional room, we're going to want to go through all of the duties and get all of the possible tasks from all the possible duties. So for each duty D in duties, and then we say for each task T in D.tasks. I guess it doesn't need to be a function. It can just be a getter and setter. Come on. Got some red here, what I'm not sure about. We'll have to figure that out. But first we're going to finish doing this. So over here in our functional room, we go through... Wow. I am not doing well all of a sudden. So then I add tasks.add t. And then we return tasks. And that'll go through all of the possible tasks and load them all up. So here in this, what we're going to do is we're going to get that list. List tasks equals local tasks. If there are no local tasks, if tasks.count is greater than 0, return tasks. Otherwise, we're actually going to want to return all of the other tasks from all of the other sectors. But there is a chance that this could cause an infinite loop. Because if there are sectors that are connected in a circuit, and they all ran out of things to do, then they'll all keep asking the next sector for all of the things that it's supposed to be doing. This is a problem. Let me think about this for a second. So basically we're going through the sectors and we are asking for all of the objects, all of the other functional rooms in that sector to give us all of their tasks. If they have no tasks, then they ask all of their sectors to pass them tasks, and that could easily end up becoming an infinite loop. So because of that, we're going to need to keep track of the tasks of the functional rooms that we have queried. Which isn't ideal, but it's also not hard, it's just kind of stupid. So, public static list functional room, rooms checked for tasks equals new blah. And this can be protected, we don't need it to be public. And here what we're going to do is we are going to start up this list if we are going to search for sectors in our subsectors. So when we ask for tasks, we're going to need to have two functions to do that. So public virtual list task chained tasks ship door from door. The problem is I don't actually know what, well, no, I can get that. That's fine. No, wait, can I? Yeah, I can get that. we're definitely going to have loops. So this is going to be critical to make this work. Basically, if we ask for tasks, then we're going to want to clear our rooms. Otherwise, we're not going to. So find tasks or look deeper for other tasks from other functional rooms, but rely on the rooms checked for tasks list to prevent loops. Find tasks or look deeper for other tasks from other functional rooms, but reset the rooms checked for tasks list to start fresh. So what we're going to do here is we are going to return the chained tasks function. So this is actually going to be look deeper for other tasks from the functional rooms, but rely on that. There we are. Find local tasks or look deeper. There we are. So here we're going to go ahead and say otherwise return chained tasks from door. See? Easy enough. Here in chained tasks, we're going to go ahead and get that same setup. List task tasks. And the idea here is that we know we're going to be looking through the other sectors from the other doors. So that's what we're going to be going ahead and finding. So for each, or for int, it's going to be an int, for int a equals 0, a is less than sectors dot length count, a plus plus. And we're going to also have doors be a list here, so we're not going to get the door list over and over. Ship door array doors equals this dot doors cache, and then we're just going to go through and check. So if doors a equals from door, continue. Otherwise, go through all the sectors and get their tasks. So the problem here is that chain tasks automatically looks deeper, doesn't it? Yeah, it does. So we're going to have this be. All right, so that's no problem. And what we're going to do here is we're going to look through all of the sector functional rooms. For each functional room, f in sectors a dot rooms. First, we're going to check and see to make sure that we are not calling from a sector that has us in it. Now, the problem with that approach is that there might be two sectors with us in it, but we'll be going through those sectors differently. No, we'll end up never going back, but that should be fine. Yeah, that should be fine. So any sector with us in it is a sector we're from, i.e. that's the door. So we're going to want to find which sector we're in. For int b equals 0, b is less than sectors a dot rooms. Hold on, no, that's not right. So we're going through all the functional rooms and all the sectors, but the idea here is that we're going to want to tell that sector what room we're in. And so we're going to need to have a from door functionality. So public ship door from door, and then we're going to pass it a functional room source. And what we're going to do is we're going to look through all of our sectors, and whichever sector has us in it is the one we're from. A equals 0, a is less than sectors dot count, a plus plus. If sectors a, that's not how you spell it, sectors a dot contains, oh, it's an array, right? Is it? Rooms, yeah, the rooms, wait. The sector should be, Yeah, it's a list. If sectors a.room.contains source, return doors A. Return null. So we're also going to go ahead and make sure that we actually have our sectors set up. If sectors.count equals 0, then we're going to want to regenerate the sectors. All right, so here what we're going to want to do is go through all of the sectors and tell it to find find systems, but in making sure that we know what door we're from. So list tasks local equals sectors f dot chained tasks, and then f dot from door this. For each task t in local tasks.add t. What's with all the barf? What's going on here? Cannot convert crew.duty to crew.path element? Oh, I changed this. Okay, so so here's the issue. Duty used to be, both of these used to be path elements, and now they're not. So we're just going to grab the path element. Oh. Wow. I need to stop programming because I am making all sorts of really dumb mistakes. There we are. All right, so basically what we've told it to do is go out and fetch all the tasks, but we're not currently updating the rooms checked for tasks list, which means we may have serious issues. So we're going to be careful to update it. And the way we do that is right here at the top, we add ourselves to it. And then here at the end, what we're going to do is we are going to skip if this is already one of the ones we've checked. If rooms checked for tasks.contains F, then continue. There we go. Easy as pie. Of course, the problem being that we don't actually have anything that generates tasks. So we're going to go ahead and do that right now. We're going to drop some duty here on this post. There it is. We're going to call this geblablablia, and we're going to go ahead and remove it from our engine. We're going to have some other method of handling the engine's elements. Not sure what that's going to be, but basically the duty is going to actually link to an engine or something similar, and we're going to have to make sure that that is the duty is going to have to link to a ship system, but it's not on the ship system, it just links to it. Now, if we do it like this, that's no good because, hold on. So the problem is that we could have any number of ship systems, and they're not locked like these are. They're not part of the same map constraint system. The duties are part of the map constraint system, but the actual ship systems can be assigned lots of different duties from lots of different places. So what we're going to need to do is be able to get all of the ship systems that a given duty is targeting and assign tasks. All right, so that's something we can do. So we're going to go ahead and get a public string. You know what? I don't know how to do this. I've been bitten a lot by bluffing through this crap in the past week. Just because the architecture should exist, you should think out the architecture before you start to program this much. And I didn't bother. And that means that I've been kind of scrambling to fix all the damage I've been doing as I've been doing it. But basically, a bridge is responsible for figuring out the sort of tasks that you would do from a bridge or involving being dispatched from a bridge. So it might be the duty of being on call at the bridge, or it could be, sending you out to the ship engines or anything like that. But the key here is that the ship systems are not actually involved because they don't do anything. They exist as a stub. So when I tell you that your task has a duty and a ship system and all that stuff, that's not really what I want to have happen. I would like it to be much more interesting. Because the bridge has to be able to determine all of the ship systems that it will be assigning duties to, including itself. So the bridge might not have any duties on it. And now I just went and changed it so there were duties on the bridge. And I made it so that when the bridge looks for duties, it looks on itself. Here. So we got two options. Either the bridge looks for duties on the ship that matches the bridge's kinds of assignments, or there are duties on the bridge that look for ship elements that match what the duties do. So the question here is, does the bridge have a list of duties, and then we form tasks to various points on the ship that those duties, interact with? Or do the ship objects have duties, and then the bridge goes and looks for duties on the ship? Now, I'm tempted to go with the bridge having the duties on the bridge for one very important reason, and that's that we may have things like ruptures or damage or fires, and those are going to pop up as things that need to be dealt with, but they're not going to be things that have duties on them because it's not really part of the ship proper. Alternately, a fire could in fact have a duty on it. When you spawn in the fire damaged mesh, it comes with a duty object. Alan Wyvern says, Heyo, I'm real struggling today, so might not be too much of a fun watch. I think that we're going to want the duties to be on the objects that need to be dutied. So the bridge wouldn't have duties on it. The bridge would be looking for duties that it would be allocating, if you see what I mean. So in order to do that, I think that what we're going to want to do is have the bridge descend from functional room into post. Whew, look at that. And what we're going to want to do here is when we get all of the list of local tasks and this stuff here, this isn't even going to be here. I guess it needs to be here, doesn't it? So can we make this virtual? I forget how to make these virtual. I think we just have to say new. Yeah, that seems fine. The solar doors don't have any. You know what? I'm going to go ahead and add some right now. Box gliders, just to have them. There we go. So, when we have this list of duties, we're going to go ahead and... This is only functional rooms. Yeah, okay, that's fine. What we're going to do is we're going to have the posts actually have a lot more functionality for this in particular. So what we're going to do is we're not going to look for duties on ourselves. Maybe we should, and also. So look for duties on ourselves and also duties on the ship that match our priorities. So to do that, we're going to want to get this same list, list duty ds equals base.duties, and then we're going to add a list of all of the duties that we can find that match our keywords. So public list string duty keywords. We'll look for any duties anywhere on the ship that have these keywords. And so from here, what we're going to do is we're going to go and get all of the duties on the ship, which we can do by simply saying, is this? No. So we're going to have to get a ship map. So path element get component path element dot map dot get components in children duty to do cashless. So this will get all of the duties, right? So what we're going to do is we're now going to go through all of those duties and add them to our list. For each duty d, so list, or it's a duty array, all duties equals that. So duty d in all duties. If ds.contains d, then continue. If it doesn't contain d, then check and see whether or not the duty is the type we want. We don't have any keywords on the duties, so public list string keywords. If any keyword matches, this duty will be included. Now, this is something where I may change my mind later and make it if all rather than if any. Well, we can change it later if we have to. Now, the reasoning for that is that on large ships, you may decide that a duty on, say, an engine on the other side of the ship shouldn't be assigned from a maintenance bay on the opposite edge of the ship, and you may want to have it so that it's only the closer bays that actually assign the duties. But I think what I'm going to do is I'm going to have the duties have a different priority based on how far away they are. So when we get to a task, we're going to have a priority. So public float priority. And the priority is going to be, I guess we shouldn't call it priority because the higher it is, the less important it is. What's the opposite of priority? Slack? Unimportance? Call it unimportance. So with that in mind, when we come back over into this functional room, we're in the post specifically, this functional room, we are going to check and see whether or not the duties exist, and if they exist with the right categories, we're going to go ahead and add them. If d.keywords, so for each here, for each string key in duty keywords, if d.keywords.contains key, then add it and break. So ds.add d break. There we go. So now we're going through the entire ship looking for any duties that match our keywords. Should be pretty simple. And now the big question, what did I forget to plug in? Because we've got to hook up everything before it'll work. And the obvious answer to that is I don't have any duties assigned anywhere right now. So we're going to go ahead and start with that. Here's an engine door. Let's go ahead and slap a duty onto it. There's our duty. And we're going to go ahead and make this duty have a keyword of 1, which we're going to call pilot. Maybe I should make it all lowercase. Pilot. And then over here in our bridge, this bridge, pilot. And then here, we have a duty here as well, which we're going to go ahead and leave as a duty of 0. We're going to call this man bridge. And I guess we're going to add pilot ship here. So that way we'll be able to handle it. Now, I don't think pilot ship is what we're actually going to call it. It's going to be something like handle engine vectors or something. But we'll figure it out later, because the basic idea is that the person's actually going to be walking over to the engine to do this. So it's not just... I guess we'll call it monitor. I don't care. Al says that Twitch is being a dick. Yeah. It might be me. Recently my RCN has been pretty poor in comparison to how it used to be. So we have some duties, and what we would like to do is test and see whether or not those duties get correctly found when we ask for them from here. But there's a lot of pieces to this puzzle, so we're going to add in some debugs. One of the debugs is we're going to have the ability to print the duties. So public void print duties, or debug print duties. I'm going to have a menu item, print duties. And so here we're going to go ahead and say for each duties, D in duties. No, that's plural again. And we're just going to go ahead and say debug.log d.name plus, yeah, just like that, that's fine. D.desk, there we are. D.name plus colon plus d.desk. Ooh, we're getting fancy. All right, so that should allow us to quickly see whether or not this duty system works. And to check it out, we're going to go up here, we're going to right click, and we're going to notice that it didn't actually take. That's because that's a duty. There's the post. Man-bridge, pilot ship. For some reason, man-bridge got caught twice. The base must have caught it twice somehow. Ah, here it is. Get components and get components and children actually end up being the same thing. So we're going to go ahead and better. Good. So now we're getting duties correctly. What we need to do is from here, we need to see whether or not we can get duties. We don't have that programmed though. So we're going to go ahead and in the functional room, we're going to want to be able to print out, same debug idea, print out all of the tasks. So that's what we'll get. We'll just have a quick little debug print tasks. And that's just a matter of going through all of the possible doors. And I guess we'll just go through the first door. So menu item, debug print tasks. And what we'll do is we'll just go through the first door. So list task. I'm trying to think if there's a problem. No, I think it's fine. List task, tasks equals tasks, and then it's going to be from our favorite door, just doors 1. And for each tasks. Oh, but you know what? That gets the duties. It doesn't get the tasks. So we're getting all of the tasks that we can using this check for tasks function here, and this chained tasks, local tasks, here it is, dduties, d.tasks, duty.tasks. Do we have tasks? We do, in fact. It's just empty. Okay, so we've got stubs. That's fine. So what we're going to do is we're going to go ahead and finish creating that, and then we'll make it less of a task system, less of a stub. For each task t in duties, in tasks, debug.log t.name plus t.target t.duty.name.desk. That should be fine. Now the problem is that we don't have any ability to create tasks for these duties. Now there are two basic approaches we can use to this. We can either create tasks on the fly, or we can have tasks that are already on the duty, and they just get activated depending on how much time passes and stuff like that. For now, we're going to take the latter, just because it's a little bit more straightforward. And we'll change it up later if we need to. So basically, if we go over into our engine room, we're going to need to have some tasks. So let's create an empty inside, call this tasks, and drop a task onto it. And we're going to go ahead and not give it a start position, but we are going to give it a duty. And we'll give it an unimportance of 10. And we're just going to go ahead and say that that is what we're going to want for our tasks. And to back that up, over here in the duty, we're going to replace this with a flat property. That way we'll be able to actually drop it in. Boom. So now, if I fix whatever bug is bothering me, oh, the tasks don't. Is it this task that's giving you the problems? Why is this task giving you the problems? If not path or path.count is less than 1, return. Why are you barfing? Grind, 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 and clear. Better. All right, so with that in mind, let's see what happens when we ask this crew quarters to get us some tasks. Let's save first in case there's an infinite loop. Print tasks. It did nothing. So I have a feeling it went out and tried to find some tasks, but never ended up actually tracking any down. So to try and make sure that this works, what we're going to do is we are going to take a quick little look here. Chain tasks. We found the duties. So if we take a look here, we're checking local tasks, I believe. Debug.log duty and then plus d.desk. Let's go ahead and just see what's going on here. Now we should be able to do this even from this room here. So let's take a look. Duty man bridge. And then it barfed. I don't know why you barfed. Next should exist. There's no way that next shouldn't exist. The only time we add is here, next door.path element. I guess it's possible that there is a next door that we didn't find. So path element next PE equals next door.path element. If not next PE, then return or continue. Oh wait, that's if it's a start element. I think that there's a problem with the ship cache, because I'm not really treating a ship cache very carefully right now, and I think it's just being garbage on me. There we are, resetting the path. And let's see what we can find here. Let's debug our duties. There we go. And now let's debug our tasks. So we're getting this, but for some reason it's barfing. On line 31? It thinks there's no next. Now, it's possible that we're adding a null value to that next stack, but I don't know where that would be happening. Well, there's the null. So we're definitely adding a null value here. The question is, where would that null value be? There's no nulls in the sectors, and there shouldn't be any nulls in the paths. Let's take a look here. If next equals start element, then next door equals the door on the other side of this one. If there is no connected room, then go away. If there is a connected room, then add the path element. So let's go ahead and just put a debug here. Debug.log immediate connection plus this. Grind, 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 and clear. Try again. So it didn't give me an immediate connection notice. So that must not be where it's happening. So there's probably a path element that's being null somewhere, but it shouldn't. There's no nulls here. Is it in the doors? There's no path element on this. There's path elements on the doors, but not on the engine. Okay. You know what? I bet that at one point these descended in different orders, and there was one, and that's the problem right there. All right, so with that addressed, let's go ahead and reset the ship and try one more time. And print tasks. So here you can see that it is a delayed connection. So those are fine. These are all pointless. No reason to worry about that. So all it's finding is the task to pilot the ship. Because the duty keywords went away. No, wait, that's fine. The man bridge isn't part of the script. That's interesting. Print duties. Clear, please. I can't see what's going on anymore. So it's definitely saying that the duties include piloting the ship and manning the bridge. But when I ask for tasks, because, oh, duh, you can't pilot the bridge because I didn't add a task to it. It's just a duty. I haven't finished establishing what the hell the duties and tasks are. Right. So let's go ahead and give this a shot now. Nothing. So this isn't properly... Oh, you know what? This isn't properly getting the tasks. The one from the bridge is properly getting the tasks, but this one isn't. And my guess is that that's because this one is not correctly chaining to all of its descendants. The bridge gets all the tasks because it's right there. But when we try and find the tasks here, what we've got to do is we've got to use the chained tasks command, at which point we'll look for tasks. So let's take a quick little look here. We're going to go ahead and just debug log. We looked in, and then for each functional room, f in rooms checked for tasks, debug.log f.name. I think I'll probably have to reprogram this whole thing. It's got a decent idea behind it, but the infrastructure is not up to par. So we looked in nothing. No, we looked in the small... Okay, so we only looked in the small dorm. We never looked anywhere else. So let's go ahead and see why that is. So we look for doors, our doors, and then we see whether or not... Okay, so if it's from the door we're looking at, then we continue. So we skip the sector that includes the door we're looking at. And that's the problem, because the door we're looking at actually shouldn't be passed. So we're looking at sectors. But in this case, we actually want to invert that. And we want to look at only doors through that sector, through that door. Bool exclude from door equals true. And what we'll do here is we'll go ahead and say that this is false. Oh, that's not it. There we are. So here we're going to go ahead and say if exclude from door, so hold on. If exclude from door, and this nonsense, continue. If not exclude from door, and doors A does not equal from door, continue. Basically, if we're excluding, then we just skip that one. If we're not excluding, then we only use that one. I don't need to do any of that. Tasks, pilot ship. Hooray! All right, so now we have the proper setup. So because we're only ever going to be looking for tasks using the tasks function from a dorm room, and we've already decided that dorm rooms can't be split up that way. They can't have multiple entrances. There's no reason for us to make it complicated. We can just go ahead and tell it to search all the doors. Duty man bridge, duty pilot ship, tasks pilot ship. Perfect, right? So that's exactly what we wanted to see. And we'll just delete that. And that means that we can now attempt to move through this bridge and onto other tasks when this bridge runs out. But you know what? I've had loads of extra time here. I've had loads of time on the stream here, and I think it's time for me to stop. Well, that took a long-ass time. I'll see you folks on Wednesday or whenever. We're so close to being able to make ships actually do stuff in terms of math, but I may have to reprogram the entire infrastructure, which sounds like a big deal, but it's just like 2 hours maybe. It's just that the actual layouts, I guess I can't think of any way to make it cleaner. I don't like the fact that this uses such a haphazard combination of doors and non-door neighbor calls and stuff like that, but I can't think of a better way to do it off the top of my head. And it seems like it's solid. Maybe it'll feel better if I have a better display method for viewing this crap. I'm not sure. I'll think about it. See you around.